Okay, this video goes along with Newton's method. Trying to show you a little bit of a shortcut here that may help. First of all, go to y equals, which is what I did already. I want you to put in the function x squared minus 2. Okay, I hope you can see that in the video. On the second line, we're going to put the derivative, which is 2x. And I'm even going to show you a different method in a little bit here that may help you with the derivative part. Now, we're going to go back to our home screen, second quit. Just clear everything off the screen. Now, my initial value that they chose was x equals 1. So all I want you to do is hit 1 and hit enter. And at any point during this video, if you're not keeping up, just make sure that you pause the video. Okay? Now, here's the newer calculators. I'm going to show the newer calculators first, and then I'll go back and show the method for older calculators. All you have to do is hit second and the negative key. What that does, it takes the previous answer. So it's actually going to plug in 1 there. Then you just put minus. Hit alpha in the trace key, and look at this little menu that's popped up. Hit enter on number 1, it's y sub 1. And again, I want you to put in parentheses, second and the negative key, the answer. Now, divide that by alpha, trace, hit number 2, which is y sub 2, and again, in parentheses after that, put the answer. Now, I'm going to zoom in on this a little bit so you can actually see what I did. Okay? Take some time to get that in there. Now, I'm going to move it over just a little bit here because I want you to see the answers that we're going to get in our table here. Okay? And you don't even need to do much more work here. Just hit enter once. Look, there's the 1.5. Enter again. There's the 1.416 repeating. Enter again. That's the next number I see there. And then the next number, it's almost exactly the same. That is literally accurate to the 1.41421. Okay? So that's pretty accurate to the number we have. It's supposed to be radical 2. That's pretty slick, isn't it? Now, if you have an older calculator, let's try this again. I'm going to clear it. And again, what you do is the same thing. You put that original value. We said, hey, it's close to 1. Just hit enter. Now, if you have an older calculator, when you hit alpha in the trace key, you're not going to get the y sub 1. So what you have to do is you have to hit the vars key right here. Right above my finger. Hit the vars key. Move over to y vars. Hit function. And that's where you find your y sub 1s and things. So first of all, I'm going to go back to my home screen. I've got to put the answer minus. And again, this is for the older calculators. Vars, y vars, function, y sub 1. And then I'm going to put the answer. You can do that the same way we did with the newer calculators. And then you can hit division, vars, move over to y vars, hit enter on function, and this time I'm going to hit y sub 2. And then again in the parentheses, I'm going to put my answer. And you can do the same thing we did. You can hit enter multiple times, and it will give you the same values we have here. And you can keep going, and it would become more accurate. Look, it's giving the same value all the time now. It's really accurate. Okay? We can do the same thing with the problem at the bottom of the page, and let me show you a different method here. Go to y equals, and let's clear everything out. And my function was e to the x plus x. And let's say you've been struggling with your derivatives a little bit, and you don't remember the derivative of e to the x, or you don't know the derivative of the function you're trying to plug in. Here's what you can do. Okay? You can hit math number 8. Now again, the older calculators, this is going to look a little different. For all of you with the newer calculators, that first spot on the D's, you're just going to put x. In the parentheses, you're going to put y sub 1. And then over here, you're going to put x. Now, what that formula does, it literally finds the derivative of your original function. Now, some of you may be like, well, I already know the derivative of the original function. Then to go ahead and type that in. Now, it's going to be different again for older calculators. Your n derivative, it's going to literally say n deriv. And what you'd have to do, and listen carefully, after n deriv, you'd have to put y sub 1, comma, and the comma's right above the 7 key. Then you would put x, comma, x, and close the parentheses. Now what this does, like I said, it finds the derivative. So My original value on this problem down here, we decided to go with 0. We're looking at this problem down here in the notes. So I'm going to put in 0 and enter. And the great thing about my calculator is I can arrow up and I can pull that formula right back up. If you have an older calculator, you just have to keep hitting second and enter until it pops back up. And watch, boom, there's the negative 1/2, boom. You'll notice these numbers are a lot like the ones I've got in my table here. And that is accurate to 4 decimal places. Look, both of those have the same numbers through 5 decimal places, even 6. So it's definitely accurate to 1 decimal place, or 4 decimal places. So this is how you can use Newton's method on your calculator, and I hope this helps you get through this lesson. It'll make things go a lot quicker. All right?